All right, so we're on part 2. So you're going to take your papers that say vertically and horizontally compressed, and you're going to write part 2 on it so that you know that this is where we're at. If you want to be even more specific, you can go ahead and write 2A.3. If you want to, you know, these are part of the 2A.3, but these are going to be the part 2 notes. I don't know why I didn't write part 2 on them for you. I really can't tell you, but this is where we're at. Okay. So we're going to start off with vertically compressed. So we should be here. Do you all see this one? All right. So if you're thinking about your interactive notebook, this should be, we just did 42. So this is going to be 43. Okay. So vertically compressed. So when we have something that is vertically compressed, means that for the transformation form, you have a times the function. You have a coefficient outside of the x, away from the x. Okay. So it's away from the x. And what that means is that we're going to be multiplying each y coordinate. Okay. So we're changing the y coordinates. And that makes sense because f of x means what? Y, right? And so you have a times y. So we're multiplying each y coordinate by that value. All right. If your a value is between 0 and 1, then it's what we call a vertical compression. If your a value is greater than 1, it's what we call a vertical stretch. Okay. How I think about the a value is working out, right? If I am going to the gym and I'm working out more and more and more, technically the whole is I'm going to stretch out. I'm going to look skinnier, right? But if I start cutting down that workout time, work out less and less and less and less, those hips are going to get wider and wider and wider. Or that belly's going to get wider and wider and wider, right? So it's going to compress and it's going to appear wider. All right. So what we're going to do is analyze that. These rules apply to any transformation. Doesn't matter the function. So we're going to be using for the remainder part of our notes is a piecewise function. A piecewise function is show you that it doesn't have to be quadratic. It doesn't have to be absolute value. It doesn't have to be exponential. It doesn't have to be any of that. Any function can be transformed. Does that make sense? Okay. So any function can be transformed. Yeah. All right. Let's get to multiplying. So we're going to start off with vertical compression. Well, stretch, sorry. So here's our first transformation rule. We have y equals 3 times f of x. Because this is your a, and your a is greater than 1, we know that this is a stretch or compress. Stretch. It's going to be a vertical stretch. And it's by a factor of 3. Okay, so these are all of my graph is here. Here are the table values. These are all of my originals. So with all my originals, boom, 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 boom. I was nice enough to type it out for you, so you'd have to write it repeatedly. You're welcome. We now are doing what to our f of x to make this transformation? What are we doing to it? I need to vertically stretch it by a factor of 3. And what? What did it say we do? Right. Multiply each y coordinate. Okay. I'm not touching the x coordinate, am I? It says each one of my y coordinates is what the change is happening to. So for this transformation, I need my new y's come from taking 3 times my old y's, right? So every y is being multiplied by 3. So we have 3 times 0. We have 3 times -5. We have 3 times 5. Dot, 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 dot. So what's 3 times 0? 3 times -5. 3 times +5. 3 times 3. 3 times 1. 3 times 2, and 3 times -3, -9. So these are my new y coordinates. Make sense? Okay, that's how you do it from a table. If you're looking at the graph, you're going to these current points. So here, I'm at -5, 0. I'm not changing the -5, I'm changing the y, right? Well, 0 times 3 is still going to be 0, right? So do I need to do anything there? No. Go to my next point. Here, I'm at -5. I'm not changing the x, but I'm at -5 on the y-axis. -5 times 3 is -15. It's going to be all the way somewhere off the board down there, right? Can't really plot it. Then I come up here. If I wanted to like stop at 2, I could. But is it going to change? No, because it's 0. I'm going to come up here. What's happened to this positive 5? 5 times 3 gave us 15. It is way off here in no man's land, right? We're going to come to our y-intercept. At our y-intercept, we're currently at 3. And we need to go up to 3 times 3 is 9. So again, it's going to be somewhere off here, correct? Here, we're at 1, 1. 1 times 3 is 3. Here, we're at 3, 2. 2 times 3 is 6. So we're going to be like just a little bit right here. Go ahead. Cannot have erased. It's going to be mad if it had erased. Are you seeing it from the table and the graph or no? And then here we're at -3. And again, that would be -9. So somewhere down there. So when I connect these points, I'm going to do my very best. This one's way off. Oh. Oh my gosh, I cannot draw a straight line. It is just terrible. Yep. Mm-hmm. She's glorious. Yep, went through that. Go all the way up. Then we're going to come somewhat down. This is terrible. Just terrible. Pretend that I'm hitting all of my points real well. Use your imagination. But do you see that it's stretched? Okay. You see where I was going with that. All right. So, can you do it from a table? Can you do it from a graph? You see what we did? All right. Guess whose turn it is? It's your turn. Okay. So you're going to identify what is your A. And then you're going to apply the A. Go. All right. Who would like to tell me what was our A value here? Our A is less than 1, right? So your A equal 1/2, which is less than 1. So we had a vertical what? Compression. So this was going to be a vertical compression, which meant that you stopped working out so much. So your graph should be getting wider. Does that make sense? Gonna look a little wider, a little fatter. Okay. So to each one of your y values, you should have multiplied by 1/2, or what's another option? Divided by 2. Okay. Multiplying by 1/2 is the same thing as dividing by 2, correct? So we have 0 divided by 2. We have -5 divided by 2, and on and on and on, right? So you have 5 divided by 2. You have 3 divided by 2. You have 1 divided by 2, 2 divided by 2, and -3 divided by 2. If decimals are your friend, then convert them to decimals. If these don't bother you, then leave them as fractions. So, but in terms of decimals, we have 0, -2.5, +2.5, +1.5, +0.5. 1, and negative 1.5. Did we do anything to our x's? So these are going to remain the same. So we are going to these set points. We are just, all right, I'm at 0. Well, that didn't change, did it? Okay. At negative 5, it went up to negative 2.5. Again, 0 is going to stay 0. At positive 5, we drop down to 2.5. At 3, we drop down to 1.5. At 1, we drop down to 0.5. At 2, we drop down to 1. At negative 3, we went up to negative 1.5. So you can see that's not very straight at the end, but for the most part, I did decent. I applaud my efforts. And so that is my transformation. I got a little wider, a little shorter, or appear to be wider. Okay. How do you feel about the compression? Remember, when you are multiplying by a fraction, that is just division, especially if it's a unit fraction. Remember, hopefully from elementary, 5th grade, you learned that a unit fraction means that your numerator is a 1. And when you're multiplying by a unit fraction, that means that you're just dividing by the denominator. Okay. All right. That's it for that one. So we're going to go on to horizontally compress. Okay. So for horizontally compressed, this still falls under our part 2. Oopsie. And we're still in 2A.3. All right, so let's talk about it. When you're horizontally compressed, that means that your transformation rule, purple is probably not the ideal color to highlight with, huh? Let's choose a different highlighter color. All right, it means that you are affecting your B. I mean, your B is affecting your X. So your transformation is with the X. Do we see that? That our transformation is with the X. So it's B times X. For A, it was outside. It was away from the X. But now I'm with the X, so that means I'm affecting the X, okay? So how does this affect our X? Well, that means we're multiplying each of our X coordinate, not by B, but by 1 over B. Does anyone know what 1 over B is called? Starts with an R. What's the word I'm looking for? Reciprocal. You're multiplying by the reciprocal. Okay? X's make things difficult. See all these things, life lessons you're getting? X's lie and X's make things difficult. That's why they're an X. Okay? It's not as straightforward. It's a complicated situation. All right? So it's going to be different. How many of you know what that instrument called? I just had a brain fart. Accordion. Yeah. I just kept thinking Urkel, and I could not get the word out of my mind of what Steve Urkel played. The accordion, right? With an accordion, when you apply more pressure, right? Because you play it horizontally, when you apply more pressure, it compresses, right? When you release the pressure, it stretches. Okay. So with your B value, it's going to be the opposite of what is with the A value. When I am applying more pressure, I am compressing. So as my B gets bigger, it's compressing. Does that make sense? When my B gets smaller, it is relaxing. It is stretching. That accordion is stretching. Make sense? We compress, stretch, compress, stretch, compress, stretch. Got it? You're playing the accordion on that x-axis, okay? So when your B is greater than 1, it is a horizontal compression. When your B is less than 1 but greater than 0, it is a horizontal stretch. Got it? Pressure, shrink it in. Less pressure, stretch it out. Yeah? All right. So let's look at our example. Here we have our transformation rule is we want to take the function and 2 times x. So we have 2 times x. So we're given our b value, right? And our b equals 2. Our b is greater than 1. So this is a compression. It is a horizontal compression. Because we're applying more pressure to that accordion, right? We're squeezing her in. Okay, because it's a horizontal compression, the change here, am I changing my x values or my y values? I'm changing my x. My y's are going to stay the same. How am I changing my x values? By what? And the reciprocal. You multiply by the reciprocal. Okay, I am multiplying not by 2. Remember, x's make things difficult. 1 over 2. So I'm taking all of my x's and multiplying them times a half. And we talked about multiplying by a half is the same thing as dividing by 2. Okay. Again, we are not doing what with our y's? Nothing. They're not being affected. But to all of our x's, so we have -5 divided by 2. We have -3 divided by 2. We have -1 divided by 2. 0 divided by 2. 1 divided by 2. 3 divided by 2. We have 5 divided by 2. If fractions bother you, what can you do? Put them in decimal. So if this is bothering you, okay? If you have $5, how much are you splitting between 2 people? 250. So we should be okay with this, right? Yeah. All right. So are my y's changing? No, just the x value. So when I come over here to this x value, my y is still going to stay where it's at, but I cut 5 in half, -5.5. So it's now at -2.5. So it's now here, right? Or not, you know, still a little extra. All right. Now we're going to keep going. We then have -3 and -3. The y is not changing, just the -3. And -3 now has to be at -1/2. Do we see that? Okay. Now we're going to go up here, -1. -1. The y is not changing, but half of -1 is 0.5. So it shifted over. And 0 is still at 3. Because half of 0 is 0. Okay. Half of 1 is 0.5. Half of 3 is, and half of 2 is 1. And then half of -5, but half of 5 is 2. Where am I at? This is 5. 2.5. And guys, I did not move over all the way. I got to stop trying to graph over it. Let's try that again. Am I there now? Yes. There we go. I was like, that thing did not shift. What are you doing? And then you, my friend, are now at 1, 2, 2, and 5. There she goes. I think I made it to all the points now. And I'm going to, again, pretend that this is like the most beautiful things you've ever seen. All right, this is going to be the hard one. Can I make it? I don't know. I'm going to try, though. Go, 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 go. You know what? She's good enough. Do you see how we compressed horizontally? All right. Guess who's turning this? Your turn. Here you go. Identify what you have and how is it changing your graph.
Would it be
All right, table group 2. What do we get for our B value? What's our B value? Your B is 1/2. Your factor that you're multiplying is what? Your factor is 2, but your B value is 1/2. Your B value is 1/2, which is less than 1, which means that this is a what? Stretch. We have a horizontal stretch. Now, by a factor of what, though? 2. Because you're multiplying by the, what's the R word? Reciprocal. And the reciprocal of 1/2 is 2. So I'm taking my x's, and to all of my original x's, that's a terrible arrow. I'm doing what? Multiplying them all by 2. Am I doing anything to the y's? Yeah, they're staying the same. So we have -5 times 2. We have -3 times 2. We have -1 times 2. We have 0 times 2. We have 1 times 2, 3 times 2, and 5 times 2. Did we get -10, -6, -2, 0, 2, 6, and 10? Yes. All right. So then we plot those points. Remember, these are your new x's. So when I go to x, my y value is not changing, right? I'm still 0, but I'm now 0 all the way over here at -10. Does that make sense? Can I go to -10? No, but I know that's where I'm supposed to be, okay? When we go to -3, -5, the -5, is it changing? No, but the -3 is. So instead of being at -3, I'm now over here at -6. Okay. We're here and where we're at. If you want to move this one, you can. It's 2 times 2. 2 times 2 is 4. So it'll be here. But it wasn't on our table, but we can do it because we know how to read a graph. All right. Here we're at -1, 3. Our new home is now at -2. I mean, not 3, 5, -2, 5. Here we're at 0, 3. Did we move? Did we move? No, we still are at 0, 3. Because 0 times anything is 0. Here we're at 1, 1. Where did we move to? 2, 1. Because 1 times 2 is 2. Here we're at 3. Where we're at? 3, 2. Where do we move to? 6, 2. So we're going to be off a little bit, right? And then I can't really do this one because it's off in no man's land. So we're going to do our best to sketch. Go, go. You can do it. And this one's going to continue. But do we see how it horizontally stretched when our B value was less than 1? Okay. All right. How do we feel about stretching and compressing? Good. If I ever say the word shrink, it is a shorter way of saying compress. Okay. So sometimes you may hear me accidentally say shrink or stretch. It's just a shorter way of saying compress.